Hey guys, this is Chris with Learn with Coffee, and today we're going to be deploying a Chainlink node so you yourself can be a node operator. Now you might be wondering, this is deviating a little bit from my usual content, but I'm going to start a new tutorial series where I'm covering blockchains, smart contracts, just new emerging technology, because this stuff is really starting to take off over the past few years. There's been a lot of advancements to make this very, very viable, and it's an awesome career path. Now, if you don't know what blockchain is, I definitely recommend you look it up, but at its barest form, it's a peer-to-peer network to where you decentralize data, and data can be verified using an algorithm called proof of work. So these nodes reach consensus and can reliably say that this data is what it says it is. And people that broadcast transactions to the blockchain, they're verified by all these peers, and these peers decide whether the data is tampered with or is changing the blockchain in a malicious way. And we found that this, in the history of Bitcoin, for instance, which is the primary use case, it's never been hacked. So we can reliably say this is one of the most secure ways of transacting data on the internet as of right now. Now, what are smart contracts? Smart contracts are a way for us to deploy code onto the blockchain so it can be executed. Now, the leading smart contract provider is definitely Ethereum, and Chainlink, for instance, is running on the Ethereum network. You might be asking, what is Chainlink? Well, Chainlink, let's just read this definition. Connect your smart contract to the outside world. Chainlink's decentralized Oracle network provides reliable, tamper-proof inputs and outputs for complex smart contracts on any blockchain. So this means, for instance, oil and gas data, verifiable randomness, pricing data, market cap data. Any data that can be defined can be put into this thing called an oracle. So your smart contracts can reliably pull from these data sources. So instead of just being isolated to the inside world of, for instance, cryptocurrency, which are just numbers that you pass between each other, it can now connect and fire off. So if I want, let's say that my oil and gas that I'm trading, once it reaches a certain threshold, I want to go ahead and transfer some funds to escrow. Well, in a smart contract, I can totally do this, but before oracles, this was extremely hard to do, if not impossible. Now, Chainlink is the premier provider. There's several other Oracle providers, but I prefer Chainlink. They have an awesome team, an amazing ecosystem, and they're only evolving day by day. And they're also within the top 5 of cryptocurrencies right now. So it could even be a solid, hey, I'm not an investor or promote any investment advice, but it is a solid investment if I were to stake or hedge my bets. So let's get into it, guys. The first step that we're going to start with doing is installing Docker. If you don't already have Docker, go ahead and go to docker.com/get-started. And if you're not too familiar with Docker, it's a way for us to package software and control the environment so it can run on any hardware. For the purposes of this tutorial, we're going to be running our Chainlink node and Postgres in 2 separate Docker containers. And we're going to create a Docker compose file that we can use to deploy these and control the different environments and inspect them. So go ahead and install this. Next, you'll need to install Postgres. Postgres is an open source SQL database. Whenever we launch our Oracle, or our Chainlink node rather, it'll go ahead and create a ton of tables for us and save information about our node. So go ahead and install this. You're not going to need to know too much about Postgres. We're just going to be doing a few commands to create the database. Next, we'll navigate over to Infura.io. Infura is a service that allows us to connect to the Ethereum blockchain. They have a lot of different tools that we can use, but right now we're just going to use them to connect to the Ropsten test network. So go ahead and create an account. I already got an account created, so I'm just going to go straight to the dashboard. Click on Ethereum, and then you'll click Create Project. Now, beforehand, I already created a project, so I'm just going to click on Chainlink node right here. Then you'll go to Settings, and down here, you have the ability to select different endpoints. So we're going to be going to the Ropsten test network. And just keep this open in the background. We're not going to be using this right this second, but you'll see here that we'll be using this link right there. All right, now that we have the basic requirements finished, go ahead and go to the GitHub link below. The repo is called Chainlink Fun. And in here, I have a README with different instructions in case you guys just want to go by this, but I'll be covering this here in the video. And click on code and copy the link. and go to a terminal and do git clone and clone this repository. And we're going to go ahead and cd into this. And you'll see here we have a couple different things. The thing that we're going to be mainly concerned about is this run node directory. So cd into run node. And we'll see that we have a couple different files, actually 3 different files, but it's hiding one. So open in your text editor of choice, whatever that might be. And we'll see that we have 3 separate files. We have a .env, a database.env, and Docker compose. So for this first configuration, we'll just go ahead and go to .env. We'll see that we have a few comments here. So I'll walk you through these different environment variables. These are going to be the environment variables that we'll use to configure our Chainlink environment. So as the first one is this root, this will go ahead and map to our volume that we're going to be creating. And if you don't know what a volume is, I'll show you here in a second. It's a Docker thing. If you're not a Docker guy, I get it. Then we have log level, debug, min outgoing confirms to, and then to the first variable that we're going to change here, we have the ETH chain ID. And at the top, we have 4 different options that we can choose from: the Rinkeby, Kovan, mainnet, or Robson testnet. And since that we're going to be working on the Robson testnet, we're going to be using this ID 3. So let's backspace this out and put 3 right there. And next we have our Chainlink contract address. This is actually where the Chainlink token contract is. So if I go over to Etherscan, this link is not working for some reason. And I search for this contract ID. We can see here that we have this Chainlink contract. So if you guys want to take a look at that, this is the one that we're going to be hitting. And this is specific to the Robson testnet. Like the mainnet one will have a separate contract ID or address. Then let's not worry about these configurations too much. We'll go ahead and cover this in a future video. There's a lot of different environment variables that we can use to define and configure our Chainlink environment. Then our database URL. So if we come over here to our database.env, this is where we define our Postgres credentials. We have a username, which is Postgres, the password, which is secret, and the database, which is Chainlink. You guys can totally change these. Just keep in mind that this is going to change what I'm doing right here. So we'll go ahead and delete that. And we'll do Postgres SQL : the username, which is Postgres, the password, which is secret, then the Docker instance name, which is PG_Chainlink. If you come over to the Docker compose file, we'll see that we have a couple services defined, and don't get overwhelmed by this. I'm going to walk you guys through exactly how this Docker compose file works and what everything is doing. And let me see if I can. Oh, that's a little bit too big. Right here is the instance name, which is PG_Chainlink. So we have that right there. Then the next thing is our default port, which is 5432. Then the database, which is Chainlink. And then we're going to turn SSL node off. Cool. The next thing is going to be our ETH URL, which, if you remember, whenever you created the Infura account, we have this WebSocket URL that we can copy and place it right here. And that's the end of our .env configuration. Now what we want to do is create a volume. Now, a volume in Docker is a way for us to relate data on our local machine to data on our container. So we'll be making a quick volume. So go back to your text editor. And inside of Chainlink fun/run node, we're going to make a new directory called Chainlink volume. And in there, we'll go ahead and go into that directory. We're going to be defining 2 different files. The first file that we're going to be defining is password.txt. This is a configuration that we'll need for Chainlink, our Chainlink node. And the first line here is going to be our username. And the second line is going to be our password, which we'll just make password for right now. And I'll go ahead and quit and save. Then we're going to be making a file called API credentials.txt. And this will just have whatever secret that you want to put here. I'm gonna put secret, but you totally could put like some random ID right here. Just make sure that you remember it. There we go. So now that we have our Chainlink volume defined, I'll go back into this. We're gonna want to add a couple different paths to our Docker. At this point, you should have Docker running, which will be located somewhere in the toolbar. You can just search it. So click on Dashboard, and that'll open up our little dashboard right here. Then we'll click on Settings, Resources, and then File Sharing. And we're going to be defining two paths here, so let me put this to the left real quick. The first path that we're going to be defining is actually the data for our Postgres. Now, I know where mine's located. Yours might be located in a totally different area, but if I go to Library, PostgreSQL, the SQL version number, and we can see here that we have this data directory. So if I type in pwd, I can copy this path right here and put /data. So that's the first one. Again, this is how we're going to be relating data on our local machine over to our hardware, or over to our container rather. Close that out. I'll cd back into Chainlink volume and get this path and copy your Chainlink volume path. And that should be it for this. So hit apply and restart, and we can just minimize this for the time being. And the next step we'll do is going over this Docker compose file. All right, so to break it down, we start with the version number, which is going to be 3. Then we define some services. The first service we're going to be defining is pg_chainlink, which will be pulling from the image Postgres. If you guys aren't familiar with images, you can come over here to Docker images. And you can see here we can add tags to make it specifically pull in different version numbers. And you can also search all of the different images over here. And we're just pulling from the default Postgres image. Then we map our port on our local machine, which is 5432, over to the port on our container, which we're just going to map to 5432 as well. We pass in our environment variable, which is this database.env. That way it configures our database. Then we define a volume. Now, once again, a volume is a way to relate data on both our machine and the container. And we'll see here that you'll probably have a different path than me. Whenever we went and did the whole file sharing resource in Docker right here, we can see that you should just be able to copy this right there. Now mine isn't going to change because I already have it saved right there. And this will map over to the var lib Postgres data. That shouldn't change on your machine since we're pulling from an image. That's the beauty of Docker, you know? Once you configure it, it's agnostic. You don't have to go and configure it for each individual environment. Cool. Now the next service that we're going to be defining is Chainlink. We're going to be pulling from the Chainlink image. Then we're passing in that .env that we defined earlier. Then this depends on the pg_chainlink container to be deployed. Then we map our port to 6688 back to 6688. Then we define our volume. Now this is going to be different. In the example that I did earlier, the path actually changed. So let's go ahead and get that path real quick, which it should just be in our dashboard again. Copy this right here. And paste it. Just validate and make sure that this link is correct, which we know that it is. And finally, the command. So whenever this runs and deploys, we're going to be running node start --password, which if you see here, this Chainlink is going to be the directory that's inside of our container, and we define that right here. So that's the root. You can totally change that if you want to. and it's going to point towards that password.txt file. Then we pass in our API credentials, which is just credentials.txt. Cool. So we should be able to run the docker compose command. So we come back over to the terminal and go into our run node directory. We can type in docker compose up. And this will run a ton of different things. Don't worry if this is overwhelming. We can see that our Postgres instance was instantiated and is up and running, but we'll also see that this is throwing an error. You might be wondering why. Well, it actually can't find the Postgres instance for Chainlink. That's because we haven't created the Chainlink database yet. So to do that, we go back to our Docker dashboard, and you'll see that you have a new cluster right here of containers. And Postgres is running properly, but this Chainlink container is not running. So to fix this, we'll click on CLI. And this will open up a terminal inside of our container. And then we want to get into our Postgres console. So to do that, we type in psql-u, which is going to be your username. If you change your username, make sure that you put the actual username that you changed it to, which is just, we have it as Postgres. Then -h localhost. And this will put us into our Postgres console. And we're going to want to type a very simple command, which is create database Chainlink. We should get validation that create database did run properly. We're now free to exit out of this terminal. And if we cancel this by hitting Control-C and running Docker Compose again, we can see that it does all of these inserts, which are just different migrations that it does, and inserts into the database. Then we see there are no accounts, creating a new account. Invalid email format. Ooh, I know exactly why. It's because we messed up a step. The API credentials is actually not this. It's actually this right here. So if we copy that and actually delete this, I got them flip-flopped a little bit. Hey, I fudge up sometimes, guys. Actually, all the time. So secret actually goes where the password.txt goes, and the API credentials is where the username and password goes. That shouldn't mess anything up, because what it did was it went and inserted all of the different migrations into our Postgres database, so that step will already be finished whenever we do Docker Compose. So it should just select from those migrations, which we can see here. And perfect. It's actually connected to the Ethereum blockchain. We can see created or connected to Ethereum node, which is that Robson testnet link. And then the ETH balance for our actual account. This is the account for the node that we're running, and how much the ETH balance is, and the address once again. So now we're free to go to localhost 6688. We can see here that it's responding, so we did 100% get that. And now, congratulations guys, you now have your first Chainlink node up and running. So to get into it, we're gonna type in Chris blockparty.tech. And then the password that we made, which is just password. And we're signed in. So you come over here, we can see the link balance that we have. That's the Chainlink balance, and then the Ether balance. And we can create new jobs. We can see how many times it runs. We can define a new bridge. We have the list of transactions, then also the configuration. We can see things like where our Chainlink root is. This is wherever we define all those environment variables. They get reflected right here. And that's the gist of it, guys. I hope you enjoyed. It was pretty simple, and I know that we didn't go into too much detail with how this actually works. But the important thing is that we got the node up and running and it's working properly. So in the next tutorial, we'll start with defining jobs and start pulling in data into an aggregator contract and start actually using that data and seeing how many nodes we can actually get to verify this data. So thank you guys again. Subscribe, like, comment. If you don't like, then I don't know, I guess I'm a sad boy.